Hello student, good morning dear student. Dear student, now today we will study in this online class of physics for 10th class. Dear student, now here we will discuss about first of all the syllabus for the second term. Second term in which you will study in this subject. There are two chapters. The first chapter is electricity and second chapter is magnetic effect of electric current or magnetism. Magnetic effect of electric current. Now here you will see first of all electricity, in which some topic already I have finished by offline, but now here you will see that the important topic in this chapter, in this chapter electricity, combination of resistances. Combination of resistances. Combination of resistances. Dear student, I told you about electric current, electric charge and Ohm's law, potential difference. Then after here, this topic is the combination of resistances. What is resistance? Dear student, resistance, it is the electrical property of conductor which oppose the flow of charge. Which is the electrical property of conductor which oppose the flow of charge. Dear student, you know that I told you conductor and insulator, the substance which allow or conduct electricity or through which we can easily flow the charge is called conductor, which have the large number of free electron. Large number of free electron which are loosely held by nuclei. Loosely held by nuclei, then their free electrons begin to move from one atom to another atom. But during the movement of free electrons, now when the atoms and ions, they collide to each other. So here during the movement of electron, here the collision between the atoms and ions. Due to the collision between the atom and ions, here the resistance arises. Resistance is the electrical property of conductor which oppose the flow of charge. Dear student, resistance we can denote by capital R. By Ohm's law, we know that V is equal to IR. You know that I told you about Ohm's law. Ohm's law gives us the relationship. This relationship between the electric current and potential difference. Okay? So here the electric current and potential difference. According to Ohm's law, the amount of current flows through a conductor is directly proportional to the potential difference. Like this. V is proportional to I, and here you can say that I is proportional to V. Now V is equal to I into R. This R, which is the proportionality constant, and it is known as resistance. What is the resistance? Resistance is the proportionality constant, and we can define by Ohm's law R is equal to V upon R. The ratio of potential and current is called resistance. Okay? So resistance is that electrical property which oppose the flow of charge, or we can define by the ratio of potential and current. Because the ratio of potential and current should be constant, then we can verify Ohm's law. So here we can find the proportionality constant, and which is known as resistance. Now you will see here the combination of resistances. Dear student, when and where you have required for the combination of resistances. Like it is usually in an electrical circuit like radio, television, and there we have required the large amount of current or small amount of current. So we have required the combination of resistances, because the electric current is depend on resistance also. And so in some electrical appliances like radio and television and other electrical appliances where we have required a small amount of current, now there and the large amount of current, so we have required two or more resistances which are combined to each other. So when two or more resistances are combined to each other, like one after other are end to end, we can say that one after other are end to end. Now this combination or this arrangement of the resistance is called in series combination, because two or more resistances which are combined in two ways, one in series and other in parallel. Okay, dear student, apart from potential difference, a current in a circuit depends upon the resistance. Part of potential difference I told you, because when we apply the potential difference, now the amount of current begin to flow in a particular direction, because all the electrons which are moving in zigzag direction. But when the cross-sectional end of conductor is connected with the battery or the combination of cell, now the potential difference which are maintained. Okay, potential difference is maintained by the battery, and now the electric current begin to flow always from high potential to low potential. Always flow from high potential to low potential. But the direction of electron always from negative to positive terminal, and the direction of current always positive to negative terminal. Dear student, here you will see that the combination of resistances we have required for the small and the large amount of current in the electrical appliances. When we have required the more amount of current, you know that because here the current, this I, which are depend upon potential difference and the resistance also. Because when the resistance is increased, now the current is decreased. Okay, and when the resistance is here decreased, current is increased, and when the resistance is decreased, now current is increased. Dear student, I told you about the factors of resistance in the physical classes, but here you will see that this is very important topic, combination of resistances. By this topic, you can revise some other topic also. And the numericals which are based on resistance and Ohm's law and the relation between resistance and resistivity, you can solve, and the circuit diagram also you can determine there in series and parallel combination. So where we have required to flow the large amount or the small amount of current, now we have required the combination of resistances, because when the two or more resistances are connected in two ways, in one series and other in parallel combination. Like we have required the two or more resistances in series combination, you will say that here. First of all, what is the series combination? When two or more resistances are connected one after other or end to end, then this arrangement is called in series combination. Dear student, in series combination, the equivalent resistance is equal to the algebraic sum of all the individual resistance. Equivalent resistance or the net resistance or the resultant resistance in this circuit in series combination is equal to the algebraic sum of all individual resistances. Okay, now here you will see that in series combination, here the combination of resistances in two ways. First in series and second in parallel. In parallel. If we want to increase the amount of current, or decrease the amount of current in the electrical appliances, now we should connect two or more resistances in two ways. In the first in series combination and other in parallel combination. Okay? Dear student, you will get the electrical circuit in which there are the mixed combination also, and that mixed combination with the two combination in the series and in parallel. So when two or more resistances are connected in one after other or end to end, then that arrangement or this type of arrangement is said to be in series combination of resistances like this. In series combination, you will show here, like you have the two or more resistances. This is in series, like this is the R1 and this is R2. When one after other are end to end, when the two or more resistances are connected one after other are end to end, now this type of arrangement is called in series combination. But when the first end of all the resistances are connected to the first common point and the second end or other end connected with the other common point, then this type of arrangement is called in parallel combination. Dear student, now we will describe the formula for in series combination for the equivalent resistance in series combination for 3 or 2 resistances. You can see here, like you have the two resistance R1 and R2, and you have given the resistance R1 is equal to, suppose that 5 ohm and R2 is equal to 6 ohm. Now the net resistance is what? You can write there R equivalent is equal to R1 plus R2. R1 plus R2, and here R1 is what? This is 5 ohm and plus R2 is 6 ohm. Now it becomes equal to 11 ohm. What is this letter? This is the sign for omega, for the ohm. Ohm is the SI unit of resistance. Ohm is the SI unit of resistance. Okay? Dear student, I told you in Ohm's law, because there you will get in Ohm's law. In Ohm's law, what you will get? V is equal to IR. From there, R is equal to V upon I. Yes? The unit of potential, this is the volt, and unit of current is ampere. What is this? Ampere. Ampere is the SI unit of electric current, and volt is the SI unit of electric potential. And here we get the ratio of potential and current, and which can define the resistance. Resistance is the electrical property of conductor which oppose the flow of charge. And we have required the combination of resistances to increase or decrease the electric current in electrical appliances or in electric circuit, like in radio and television and other electrical instruments or other electrical appliances. There we have required, if we want to increase the amount of current or decrease the amount of current, now we should connect all the resistances. It means 2 or more resistances in series and parallel. In series and in parallel. Dear student, when we want to increase the total resistances, then the total resistance, then the individual resistance are connected in series. And when we want to decrease, then the total resistance which are equal to the individual resistance in parallel. It means we should connect 2 or more resistances in parallel to decrease, and we should connect 2 or more resistances in series for increase the amount of current. Okay, so where we have required to increase or decrease the amount of current, so we should connect 2 or more resistances in series and in parallel combination. Now we will describe here in series and parallel combination of resistances by taking 2 or more resistance or 2 or more resistors. There are 2 words. One is the resistor, another is the resistance. Resistor is only an object, but the resistance is its electrical property. Like this is resistor R1 and R2. And this is 5 ohm and 6 ohm is the resistance. This is the electrical property of a conductor, and resistor is only an object. Okay, so here you will get the ohm. Ohm is the SI unit, like this. Ohm is the SI unit, and we can denote by omega. Ohm is the SI unit of electric resistance. Okay, and volt is the SI unit of electric potential, and ampere is the SI unit of electric current, and Coulomb is the SI unit of electric charge.